Hello and welcome. Now, it doesn't matter if you are doing your GCSEs, IGCSEs, or any top tier GCSE exams. One of the grade 9 killers is theorems. Theorems is one of those topics that students will always struggle in. They will struggle to find the angles, they will struggle to identify the angles, they will struggle to know where exactly is the angle we are looking for. Today, I want us to take a few minutes to look at these particular areas. We are going to break down circle theorems into various simple ways that we can be able to relate to, and then give tips on how we can always be able to identify these theorems. That is going to be the basis of today's lesson. So to kick us off, we are going to start with the basics. So when we talk about the basics, we are talking about the basic theorems. So our first ones are what we call the basics. Now the basics are those theorems that are so easy to know and are so easy to understand. When it comes to the basics, these theorems normally carry very few marks. And then we will look if maybe in our next video, we can look at questions, how to answer questions that require you to give an explanation on what you have. So let's get to the video. Welcome. The first theorem that we look at is one of the simplest and easiest theorems. And this theorem says the angle at the center is twice the angle at the circumference. So the angle at the center is twice the angle at the circumference. Let's visualize what this looks like. So if we have a circle and we have a circle center O, so we will mark the center of the circle and say that our circle is center O. That is the center of the circle. So the center of the circle is O. Then if we draw two lines from the radius so that they join the circumference at at 2 points like that, and we will label these 2 points A. So this is point A and this is point B. So we have point A and point B. So point A and point B will create an angle at the circumference. So the angle that we have is usually extended up like that and then like that, forming an arrowhead. Now, although we always look at it as an arrowhead, even if this angle was to be drawn to the side like that and like that, so it doesn't go necessarily like the arrowhead, it extends itself to the side. This is still angle at the circumference with the angle at the center. Now, normally, for most circle, or for the circles we find in the exam, the center is O. And this is, we can label this point C. So normally you look at the 2 points that I have, do they form an angle with the center of the circle? If they do, then I know that angle AOB, with O being the center of the circle, is equal to 2 times angle ACB. You notice what has changed? What has changed is O to C. The first, where the angle starts and where the angle ends, remains the same. Such that if this angle here is 2x, then this angle here is x. So one angle is 2x and the other one is x. So this is the first of the easy, this is the first of the easy angles, and it tells you that the angle at the center is twice angle at the circumference. So that is the first one. The second of the basics is angles in a semicircle. So the one at the basic is angles in a semicircle is 90 degrees. Angles in a semicircle, angles in a semicircle is 90 degrees. Let me place the degrees up there. So that is our second rule. So our second rule tells us that if we have the diameter, now in the exam, they will always tell you the diameter. They'll tell you, oh, this line is a diameter, or this line passes through the center of the circle, or the line is drawn in such a way that when you see it, it marks for you. Remember, the center of the circle in most questions is always marked with an O. The standard marking for the center of the circle is an O. So I will look at it and go, this is my circle. So let's draw our circle. So let's draw our circle. And now I have a circle of a funny color. Let me get the right color. So let's draw a circle. So this is our circle. And in our circle, we mark the center of the circle. And then we draw a line. We draw a line that passes through the center from end to end, like that. Let us label this line the line AB. Now, if a line passes through the center, line AB, then any angle it forms with the circumference is 90 degrees. And this is one of the easiest ones to identify. I just need to identify the diameter, and then if I have identified the diameter, then I can be able to identify that this angle is 90. Therefore, angle ACB will be 90 degrees. So that is the second one. So we have already looked at the first one. Angle at the center is twice angle at the circumference. And the second one, angles in a semicircle add up to 90 degrees. So let's look at the third one. Let's look at the third one. And in the third one, we look at angles in the same segment. Angles in the same segment are equal. Normally we say angles subtended by the same arc are equal. That's the rule. The rule is angles subtended by the same arc are equal. So if there are two angles, three angles, four angles that are subtended, they come and start at the same point and end at that same point, then those two angles are equal. Let's have our visualization. So if we create a circle, not a very big circle, just enough. Now, if I have an arc or a chord, so I have 2 points. Let me mark 2 points. So I have point A and I have point B. Now, any angle that they create will be equal. So, or I can join a chord here to separate that arc from the rest. So we see the segment. So this is a segment. So angles in this segment will be equal. So if I draw an angle like that and another angle like that, and I draw an angle like that and another angle like that, and I draw a third angle like that and another angle like that, to draw, looks like an origami flower. If I do that, and I will label this one C, D, and E, you will notice that angle BACB is going to be equal to angle MDB is going to be equal to angle MEB. These three angles are equal. And what do you see changing? The the letter that starts the angles remain the same. The letters in the middle change. So anytime I look at an angle and I see that the first and the last letters are the same, only the middle one is changing, then those are angles in the same segment and they remain the same. The last two theorems are usually the ones considered as grade 9 killers. They are for the students who are aiming to get grade 9. One, because they are more difficult to identify. You have to really look at the shape properly, and especially if the shape has so many other triangles in between, it might be hard to identify these two parts. One involves the angle in different segments. The rule is very simple. The angle between a tangent and a chord equals the angle in the opposite segment. So, or sometimes we say angles in opposite segments are equal. Either of the two would be able to give you the same results. And sometimes we are not able to see this, or we are not able to find it more directly. So we struggle to be able to identify where it is. So if we draw a circle, that let's attempt that again. We draw a circle. Okay, I think I know where the problem is. I'm supposed to release the circle before I release the shift button, and we draw a tangent to this circle. So that is a tangent. And then we draw a chord. So we have an arc like that. So this chord makes an angle with the tangent, and this extends to make another angle at the other end like that. So let's label our parts, because once we label, it becomes quite easy to notice. So this is point A, this is point B, this is point C, and this is point D. So what we are saying is that the angle here, x, is equal to the angle here. So angle TBA is equal to angle ABC. And that is what we say. This angle is in the other segment, and the other angle is in the opposite segment. So this angle is mirrored on the other side. And so it becomes, sometimes you might not be able to see it. But once you identify the angle, normally in the exam, when you see a tangent, the moment you see a tangent, look for every law that relates to the tangent. Think of them. Which law relates to the tangent? And then put those laws first. And finally, our final law is going to be the radius will always cut. So we say it in the final law, we say a radius that cuts a chord at 90 degrees. So a radius that cuts a chord at 90 degrees always bisects. So always bisects the chord. So what does that mean? It always splits the chord into two halves. Most of the time, this question involves Pythagoras theorem in disguise. So whatever is happening in the question is that what we are dealing with when we are dealing with this last part is the questions involved will always involve some sort of calculations that bring in Pythagoras theorem. So what we are saying is, if we have a line from this point to that point, and another line that is the radius of this circle running like that, then the radius, so this is the center of our circle O, this is A, this is B, the angle here is 90 degrees, then this side is always equals to this. And so this question always comes on the when we are dealing with the chord properties, chord and tangent properties, it's when you are able to put this, in perspective. Now, sometimes when just a final tip, you find yourself stuck in the 5 marker question and nothing seems to work. Remember that the radius will always form an isosceles triangle, and angles in a triangle add up to 180. So if you can solve any triangle by looking for points and using 180, then you can always write that angles in a triangle add up to 180. I'm going to attach a summary of this and a few worksheets that you can work on just to help you do more of circle theorems. And as you are able to look at them and as you are able to do them, send me the questions. I'll put the link in the description below. I'll see you in the next one.